Space, the final frontier, has captivated human imagination for generations. We've made incredible strides in exploring the cosmos, launching satellites and space missions that have revolutionized communication, weather forecasting, navigation, and scientific research. But as our presence in space grows, so does the risk of a significant problem: space debris. Often overlooked, space debris poses a severe threat to current and future space activities, astronauts, and even us down here on Earth. The growing menace of space debris. Space debris, often referred to as space junk, is an ever-increasing menace lurking above our heads in the vast expanse of space. Picture space as an enormous sea, with satellites and spacecraft bobbing and weaving through it like ships on the ocean. However, unlike the ocean, this space sea has accumulated a significant amount of debris over the years, ranging from defunct satellites to fragments from collisions and discarded rocket stages. This cosmic litter orbits the Earth at breakneck speeds, and collectively, it poses a major threat to space activities and the safety of astronauts. The origin story of space debris dates back to one of humanity's most significant milestones, the launch of Sputnik 1 in 1957. With that historic event, we ushered in the space age, propelling us towards an era of exploration and technological advancement. Little did we know that our early ventures into space would have long-term consequences. As more objects were sent into orbit, some of these spacecraft were simply abandoned, turning into the earliest pieces of space debris. Over the decades, as space missions and satellite launches have become routine, the amount of space debris has grown exponentially. What was once an afterthought has now evolved into a critical problem that demands our attention. Space missions and satellites play a vital role in our daily lives, from enabling communication to monitoring weather and traffic navigation. However, the increasing risk of generating more debris poses a significant challenge to the continued success of these ventures. Perhaps one of the most troubling incidents contributing to the space debris crisis occurred in 2007, when China conducted an anti-satellite missile test. The test targeted one of its defunct weather satellites, resulting in the creation of thousands of additional debris fragments. This event was a wake-up call for the international space community, underscoring the potential for intentional actions to exacerbate an already complex problem. The consequences of space debris are not to be underestimated. Collisions between space debris and operational satellites or spacecraft can also cause extensive damage or complete destruction, leading to communication blackouts, data loss, and financial ramifications. Moreover, there is a real concern about the Kessler syndrome, a doomsday scenario where space debris collisions cascade into a chain reaction, rendering certain orbits unusable for generations. Space debris also poses a direct threat to astronauts aboard the International Space Station, or ISS, and any future crewed missions. The ISS is equipped with systems that can maneuver the station away from potential collisions, but not all satellites and spacecraft have such capabilities, leaving astronauts vulnerable to this celestial hazard. Space debris, seemingly distant and intangible, has the potential to unleash a host of grave risks that demand our immediate attention. Let's explore these risks as they shed light on the imminent dangers lurking above our heads. Number 1. Collisions. Space debris zooms through the cosmos at breakneck speeds, often exceeding tens of thousands of kilometers per hour. When these debris pieces collide with operational satellites or spacecraft, the consequences can be dire. Such impacts can cause severe damage or, in worst-case scenarios, lead to complete destruction. As a result, critical data loss, communication disruptions, and financial losses can cripple the functionality of vital space assets and interrupt services we heavily rely on down here on Earth. Number 2. Kessler syndrome. Back in 1978, NASA scientist Donald J. Kessler introduced us to a chilling concept: the Kessler syndrome. This hypothetical scenario paints a bleak picture where the density of space debris reaches such a critical point that collisions between fragments create even more debris. In turn, these cascading collisions trigger a domino effect, multiplying the number of debris pieces exponentially. The resulting catastrophic cloud of debris could make certain orbits inaccessible for generations to come, transforming the once majestic expanse of space into a perilous and hazardous environment. Number 3. Threat to astronauts. Astronauts are daring pioneers exploring the final frontier, face an ever-present threat from space debris. On the International Space Station (ISS) and during future crewed missions, these brave souls are vulnerable to the potential devastation caused by collisions with space debris. While the ISS employs sophisticated systems to maneuver away from potential hazards, smaller satellites or missions might not have such capabilities, leaving astronauts at risk of facing an unavoidable and dangerous rendezvous with debris. Number 4. Tumbling debris. Some larger space debris, such as spent rocket stages, exhibits unpredictable behavior while orbiting our planet. Like a wild acrobat tumbling through the cosmic circus, these objects experience erratic and challenging to predict trajectories. This unpredictability further compounds the risks of collisions with operational satellites and spacecraft, raising concerns about the safety and stability of our technological endeavors in space. Number 5. Re-entry hazards. The journey of space debris doesn't always end in the vacuum of space. Some debris fragments re-enter the Earth's atmosphere, creating a different set of hazards. Debris containing hazardous materials poses a tangible threat to life and property on the ground. While most objects burn up during re-entry, larger pieces can survive and crash down to Earth, potentially causing damage or even endangering lives. Current efforts to mitigate space debris. As humanity's footprint in space continues to expand, so does the growing concern of space debris. A cloud of defunct satellites, spent rocket stages, and fragments from collisions, space debris poses significant risks to our space activities and the space environment itself. However, recognizing the gravity of this problem, various international organizations, space agencies, and private companies have stepped up their efforts to tackle the menace of space junk. Here are some of the key initiatives they've undertaken. Number 1. Space traffic management. Imagine a busy highway where vehicles are zipping around at breakneck speeds. Now picture that in space, where satellites and space debris are moving at even greater velocities. Space traffic management is a crucial aspect of mitigating space debris risks. Organizations are actively monitoring the trajectories of active satellites and space debris to predict potential collisions. By doing so, they can alert satellite operators of any collision risks and enable them to take evasive action, ensuring the safety of operational satellites. Number 2. Deorbiting and disposal. A significant part of the space debris problem comes from defunct satellites and spent rocket stages that linger in orbit, posing collision risks for years. To combat this, modern satellites are now designed with propulsion systems that allow them to maneuver into a lower orbit at the end of their operational life. This maneuver, known as deorbiting, accelerates the satellite's descent into Earth's atmosphere, where it burns up harmlessly. By reducing the time a defunct satellite spends in orbit, we effectively reduce the chances of potential collisions. Number 3. Space debris removal missions. Innovative minds are exploring out-of-the-box solutions to directly tackle the space debris problem. Company and research institutions are actively working on developing spacecraft capable of capturing and deorbiting defunct satellites and large pieces of debris. These ambitious missions aim to actively remove space junk from orbit, reducing the overall debris density and the risk of collisions. Number 4. Sustainable space practices. Preventing space debris in the first place is just as essential as cleaning up existing debris. Organizations are now adopting guidelines and best practices to design satellites with fewer materials that remain in orbit after their mission completion. By ensuring that satellites re-enter the Earth's atmosphere and burn up within a reasonable time frame, we can reduce the accumulation of space debris over the long term. Conclusion. Space debris is a critical issue that demands our attention and collective action. By adopting sustainable space practices, investing in space debris removal missions, and fostering international collaboration, we can work towards a cleaner and safer space environment. What do you think of this? Let us know in the comments section below, and make sure to like the video and subscribe to the channel.